Very good. Yeah, as Ron mentioned, many people may know Suse as a Linux provider. And in the last 4 years, we've really expanded significantly beyond that to a cloud native infrastructure solution, all the way from the operating system through the container platform, and really about securing that entire ecosystem. Today, I want to talk about the challenges and strategies for securing the dynamic environment of a modern enterprise. I look at a modern enterprise as really a distributed enterprise, one that's rapidly delivers the secure cloud native applications and data across core, cloud, and edge, for an operational and competitive advantage. The technologies and processes that have enabled this agility are great for the enterprise. And we just heard, on low code and the capabilities that delivers and how to rapidly iterate. But they are also great for opening new doors for harmful bugs that enable the malicious attackers. And so let's talk about how that's evolving and how do you address that. Once protecting the traditional environment or traditional enterprise was straightforward. Physical security, traditional networking and firewalls, and reasonable identity access management. The cloud then began to open the infrastructure and applications beyond the tightly controlled data center. And now that is evolving into a global shift, as digital transformation continues to gain momentum. Effectively, every enterprise is becoming a distributed enterprise, able to intelligently place applications and data across core, cloud, and edge to deliver an always-on experience, digital businesses demand. Making this shift is quite complex for IT organizations. You're expected to deploy, scale, and secure a distributed architecture that interoperates seamlessly across a hybrid multi-cloud estate and an exploding number of edge use cases. You have to build, modernize, and migrate applications to cloud and cloud-native platforms without disrupting the operations of critical business applications. And all of this amongst an extreme industry talent and skills shortage. So, it's no longer about just ensuring security, or no longer is ensuring security of this distributed estate about securing a data center and physical networks, or even logical networks. You must maintain a trusted software supply chain and runtime environment, ensure governance and compliance standards are met across that ecosystem, and respond real time to newly discovered vulnerabilities on what seems like a daily or weekly basis. So traditional defenses are still absolutely required. Perimeter and identity attacks continue as evident in recent Google and Microsoft attacks. However, new infrastructure models, rapid and leveraged application delivery models, and in the wild distributed ecosystems have greatly expanded the attack surface, and threat actors have become much more creative and aggressive in exploiting vulnerabilities in these vast and rapidly evolving ecosystems. Some recent examples of this include the Havana crypt posing as a Google software update before it holds data hostage. The NitroCod malware delivered through legitimate application installers sits quietly for weeks, erasing its evidence of its installation footprints, before seizing your system's GPU to mine cryptocurrency. SolarWinds' now infamous supply chain exploit that put all of its customers at risk. And then most recently, the Log4j exploit that hit nearly every company on the planet. So as you are all experiencing, cloud native technologies are becoming the norm. More and more Kubernetes and container environments are going into production, not just in sandbox environments, but real environments where there's sensitive data to protect. There's PCI compliance and other types of compliance that needs to be ensured. And applications are being deployed using continuous delivery methodologies, introducing ecosystem changes on a daily basis. In containerized Kubernetes and cloud native environments, traditional security tools that you're used to deploying whether it's firewalls, intrusion detection or prevention devices, malware, scanning, or any of these are incomplete or just don't work relative to the needs of the business. They're not going to provide the visibility and protection that you need. A specific example is Kubernetes has a layer of network abstraction that really makes it impossible for any type of traditional network security tool to see the network traffic between containers and to understand what's going on and determine if there's an attack happening. This requires you to have a solution designed specifically for a containerized Kubernetes cloud native architecture. And then, as mentioned, and I hear regularly, and talk to company executives and they say, hey, Brent, these technologies and operation methodologies all sound great, but we can't hire or train enough people to deploy and operate at scale anytime soon. This is a challenge every company, facing every company, and is demanding the need for solutions that are easier to use and more complete in their coverage, reducing the need to integrate and manage numerous disparate solutions, from a number of vendors, and really mitigating the risk of adopting new technologies, lowering the probability of error and failure in deploying new technologies. And this really leads to the last challenge and need for change that I want to highlight, and that is automation. Again, more and more deployment teams are implementing rapid or continuous application delivery methodologies to keep pace with today's dynamic business requirements. When deployed in full, a distributed enterprise has thousands or tens of thousands of interdependent services, likely deployed across local data centers, multiple public clouds, and out in the remote edge deployments. The dynamic nature, vast services, and sheer velocity of change in these ecosystems make manually managing security details completely infeasible. Automation must be deployed across the spectrum if there's a chance for security to keep pace with the change. Alternatively, security becomes the bottleneck to rapidly meeting business needs. So to address these challenges, you can't rely on a single security methodology for protecting critical processes and data. You must apply a layered security methodology that can be applied across the full application and infrastructure lifecycle. This is typically referred to as defense in depth. A layered security strategy has multiple ways and opportunities to detect an attack or exploit in progress and to prevent or limit any damage, which is why it's critical to have a layered security approach. On the surface, this appears very complex, with various tools applied at numerous points. And honestly, it isn't simple, but it shouldn't deter you from a holistic defense in depth strategy because it is the most effective approach in today's modern ecosystem. Our goal at Suse is to make it less complex and easier to deploy and operate versus many of the alternatives. So let's walk through a few of the key layers of a defense in depth approach. Let's start with vulnerabilities and compliance. The first concept everyone must understand today is the need for full lifecycle coverage, pipeline to production. This should be obvious from many of the recent high visibility exploits, starting with the supply chains. Developers, ISVs, leveraging open source projects, create numerous entry points for vulnerabilities and exploits to come into your ecosystem. So you need to be able to monitor and trap vulnerabilities throughout the build pipelines, whether it's from a developer, they're building their own code, whether they're using external projects and integrating them into applications that they're building. And then beyond the build processes, images that you may bring in from third parties or projects and store in repositories. You need to be able to continually scan that infrastructure, those repositories for newly discovered vulnerabilities. CIS benchmarks and policy enforcement needs to be applied throughout the lifecycle. You want to ensure that you don't inadvertently have misconfigurations in the environment. You want to be able to inspect for secrets or open file permissions or other compliance violations that you might have throughout the ecosystem, whether it's in your build environment or in your runtime environment. And then compliance analysis must be introduced, particularly in highly regulated environments, and be able to produce compliance reports that help with PCI, GDPR, or other NIST audits. And then continuing that into the runtime scanning, the production environment, being able to detect and remediate recently discovered vulnerabilities, and automatically quarantine an infrastructure or applications if they have a critical vulnerability. So these are kind of all the elements that are in that compliance vulnerability scanning environment. And you need automated capabilities to be able to do this all the way from your initial supply chain throughout the build pipeline and into the production environment. The next area I want to talk about is kind of modernizing that protection ecosystem. I mentioned the shortcomings of legacy approaches to securing a runtime environment. There are numerous modern technologies and techniques that can be applied to better protect your modern infrastructure. First, protecting the runtime environment from pipeline-induced vulnerabilities is through admission controls. This is essentially putting a gatekeeper at the entrance of your production environment to check deployments against your security policies prior to launching them into production. Vulnerabilities, compliance, configuration deviations, and new vulnerabilities can sneak into the environment at any time, and checking them at the point of deployment helps prevent that supply chain and build time environments issues from coming into that production environment. So now the cloud native ecosystem of Kubernetes and containers requires the new capabilities that I mentioned. And this is largely due to the container to container communication ecosystem that sits hidden from traditional firewall and network monitoring tools. So a key protection needed is a layer 7 container firewall that is specifically designed for Kubernetes and containerized environments. And this should enable inspection of all network traffic within a Kubernetes environment, whether it's east-west traffic, pod to pod, ingress and egress, to look for any types of violations or network attacks. And then you want to also ensure continuous container workload security through inspection and monitoring of every runtime container, including containers or microservices that make up your application, as well as system containers. You want to make sure that there's no unauthorized processes or file activities occurring within those containers or on databases and in ingress and egress ports that you may have in the environment. So next area is zero trust. Historical approach to security is to identify what is not allowed or what creates risk, an attempt to prevent that specific set from occurring. However, this requires knowing what is bad ahead of time and continually maintaining that list, which in today's environment is really impossible to accomplish. So an effective approach that needs to augment the traditional monitoring and vulnerability inspection techniques is one that we enable with Suse's new vector is a zero trust approach, which is to define a list of allowed behavior for your container. What are the allowed network connections, the allowed east-west, as well as ingress traffic? What are the allowed process and file activities in a container? Everything else is untrusted and can be blocked if set to that protect mode. This is probably the most crucial element in detecting and trapping attacks at day zero, or even beyond, when critical business processes need to continue to operate, even though they may contain known exploits. If we take log4j as an example, because it's fresh in everyone's mind, it was latent in everybody's ecosystem, in the build environments, in the runtime environments, et cetera. And at day zero, clearly nobody had any protections in place against this or detections for it. It took days and weeks to find where it was at in your ecosystem, weeks to months to get new applications developed and deployed throughout the ecosystem. But with a zero trust implementation approach in place, the exploit even being there would have been blocked in the vast majority of cases, because the behavior that was used to get data out to take advantage and exploit the vulnerability would have been an abnormal behavior and not allowed in the vast majority of ecosystems. So we find that most people that had zero trust enabled in the new vector environment could continue to operate while they put mitigation processes in place and brought in the updated applications, and they could operate it with a high degree of confidence that they were protected from the exploits and the egress of data in that particular context. So now the challenge: how do you possibly maintain and manage security amidst hundreds of developers and suppliers releasing monthly, weekly, or daily as soon as code is ready? Against a backdrop of spooks and roaches, releasing new threats on a weekly and daily basis. You must automate, again, from pipeline to production. You must have policies that are effective at blocking the bad guys and even blocking unknown attacks. So just how do you get those policies? Manual creation. In the totality, this is just too slow. It reduces developer agility and is error prone. A better solution is automation through behavioral learning. Let the system learn during development, testing, and staging what the appropriate and expected behavior is. Test that out and make sure that, yep, what we've got happening, we've covered all of the operational processes, and the system can learn what those normal behaviors are. And then once that appropriate behavior is learned, all other behavior is deemed suspect. And then once you put that into production, the system can warn of unusual behavior, or if you have the policy set to automatically block, it can prevent any of that behavior, any unusual behavior from happening automatically. And so that system can continually monitor what's normal behavior. You can continually update that and keep that in place, and really helps you scale and have the speed and agility that you need in today's fastly changing environment. Going in hand with that is policy as code. And whether that code is automatically generated through the behavioral learning or developed during the application process, the application development process, and the infrastructure definition process, policy as code allows you to store those policies in your code repositories just as you would the application code. Now it can be revisioned, updated, and deployed in lockstep with applications in real time. And so you're not waiting for security policies to be developed after the application has been developed and tested. It's done throughout the process. So CI/CD pipelines, rapid DevOps delivery can be as effective as possible and not slowed down at all. So that kind of brings us through some of those major building blocks of a defensive in-depth strategy. And the areas that Suse's portfolio can now help you accomplish implementation of that defense in-depth strategy. Looking at recapping those various environments, you absolutely need to protect pipeline to production. Having a single solution that can see that entire spectrum, provides you, significant advantage to trying to piecemeal that together at each step along the phase. Second is modernize your runtime protections. Have a firewall that is Kubernetes aware, that is container aware, cloud native ready, capable of inspecting packets at real time and putting those protections in place. And then trust no one. Having a zero trust strategy in place dramatically helps, particularly once an exploit is found, because it's clear in today's environment that it's not if you're going to be have an exploit or a vulnerability exposed in your environment, it's when. And being able to block those and mitigate those risks and vulnerabilities once they're in production or as they're in production, and be able to keep operating with a high degree of trust is critical to your business. And then implementing automation across that spectrum. So with that, I thank you and willing to take questions, or if you want to follow up afterwards, absolutely can reach out to me at brent.schroeder at suse.com.